Okay. We're going to be looking at the 2018 questions number 1 and 2 today. We're going to take a real quick look at these two. They're really simple. In fact, we might have done both of these. I can't remember. I know we've done number 2. We may have done number 1 occasionally in the past. But I'm going to go through this real quick and kind of talk about how you can get a full score on these. We can see in number 1, you've got a scatter plot. You've also got a printout of a regression output. So we're going to kind of zoom in and look at part A. Part A says to identify and interpret the context of the estimate for the intercept of the line of best fit. And I've labeled those here. You can see that the first value is the y-intercept. The second value is going to be your slope. A lot of this other stuff we would have learned back in chapter 27, but since that part kind of got axed at the end of the semester, you won't really be required to know it. The parts that you do need to know, so if you get a question like this, you need to know the y-intercept, you need to know the slope, you need to know that this is the standard deviation of the residuals, you need to know that this is where you get r squared as well as the square root of this value is r, but r squared is always a positive number. When you take the square root of it, it's still going to be positive. So we have to kind of go back to our slope. We have to kind of make sure that the slope and the the slope and the r value kind of match up with their signs. If they don't match, then you got the wrong value. So make sure that you're looking at this when you look to find your r value. It didn't ask us for that here, but just FYI. Letter A. The things that I needed to do to get this correct number 1 was I needed to make sure to mention the actual value of my y-intercept, right? 72.95. And then I needed to make sure I interpreted that in context of the problem. So I said this: if there were no customers in line, or if there were 0 customers in line, I need to make that comment, then I would expect to wait approximately 72.95 seconds, or approximately 73 seconds. That would be all of that would be fine. To get credit for this particular question, you had to do 3 things to get it fully correct. Number 1, you had to correctly identify the numerical value of the y-intercept, the 72.95. Number 2, you had to include the idea that the intercept, the interpretation, included the fact that you had 0 customers or no customers at all. And 3, or it had to be in context. Number 3, you also had to talk about this was an estimate. It was not an exact value. Either I can say I would expect, it's estimated, it's predicted, it's on average. Any of that kind of vocabulary would have gotten you full credit. And that's, I've kind of put both of it. I said expect, then I said approximately at the same time. And that would have given you full credit for part A. Okay, go down to part B. Interpret the context of the coefficient of determination, r squared. Remember, coefficient of determination is r squared, and correlation coefficient is r. And so I went ahead and went up here. R squared is 73.33%. 73.33% of the variation in the y variable, which in this case is time, can be explained by the variation in the number of customers in line. You could have said a whole lot of things there. Could have talked about waiting time. I didn't go all the way into that. In order to get part B correct, it's kind of the same thing as in part A. Number 1, you had to correctly identify the numerical value of r squared, 73.33. 2, you had to provide a correct interpretation of r squared. Now, this could have been generic, or it could have been in context. Now, to get full credit, that's the third part, and that's to put it back into context of the problem. You had to talk about waiting in line, or just waiting, and then it depended on the number of customers in line. Okay, and then lastly, part C. This says one of the points was determined to be an outlier. Circle the point in the scatter plot and explain why this is considered an outlier. Obviously, I have that circled up here. The reasoning is we're going to be explaining why this is an outlier. It can do a lot of different things, whether it's, I can interpret it as, well, number 1, you had to do 2 parts. I had to circle the outlier in the right, I had to get the right point, right? So that's this one. That was pretty obvious. The second thing, and I said it circles it because it falls farther away from the line than we'd expect it to, and I was alluding to that this point has the largest residual of any other point. I used the residual as my evidence to show that it was an outlier. There were three things they suggested that you could have said. I could have said that it's in terms of combinations of x and y values, it's unusual compared to the other points. So if you said something like that it's in an unusual place, it's much lower on the y value than you expected it to be, if it has a large residual. Those are the three options. And if you have other options, there's quite a few other things here that they can talk about. You can look that up on the key that I'm going to post. But you had to give me some sort of evidence on why it was an outlier. You couldn't just say, oh, there it is. If you did those two things, you would have gotten full credit for that. And this question's really easy. Usually number one is typically easier. I would definitely not expect something to be this straightforward on the test this year. I would expect this to be maybe the beginning of a question, and then you're going to have, okay, now let's move on into the next part. I wouldn't be surprised to see linear regression. It tends to open up lots of options, and you can kind of take this and ask lots of different things. So this can end up being one of those types of questions where you can do a lot of things with it. So I know a lot of you don't like this stuff, but don't shy away from reviewing it fairly well. Let's go on to question 2. In question 2, we are looking at and this is the one we've done before. I know we've done this one. An environmental science class is talking about recycling plastics. And the question is asked by the teacher to all of the students as like a survey. Do you regularly recycle plastic bottles? And took a poll. And the first question was like, well, how many students did the teacher ask? Well, if you look up the confidence, and this is categorical, it's a yes or no question. So if you look up the formula for margin of error, and I've written that down. I wrote down the full, the full formula for the confidence interval. Really, the part that I'm really going to be focused on is this piece here. Let me just kind of pull this over. What you're looking at is, number one, I needed to find what p hat was. I needed to know what the center was, right? I needed to know what p hat, q hat, and z star is. I need to know all of those things, and I need to know what the margin of error is in order so I can work this out. Anytime you're looking at sample size, this is kind of the method we've always done. But this time, they didn't really give us a lot. They gave us the interval and the confidence level. And so in order to get p hat, I can add the endpoints of my interval and divide by 2 because it's the midpoint. My z-star, easy. It's just 1.96. That's something I could look up. Q hat is the difference of 1 minus p hat. So I can do that real quick as well. Here's the formula for margin of error, just kind of isolated. I went ahead and plugged all that stuff in. And now I'm going to find margin of error. Well, the margin of error is the difference or the distance from the midpoint to one of the endpoints of my interval, right? So however you want to think about it. A margin of a confidence interval is always 2 margin of errors wide. So from the upper bound to the lower bound, it's always 2 margin of errors. So I subtract it to get the endpoints, and then I divide it by 2 to get that value. Okay, and you can see that calculation here. The next thing I did was I set the 0.116 equal to this formula here, and worked it out. And the first thing I did was I divided by 1.96 to get rid of this value here. And to divide that, you're going to get 0.0592 equals I went ahead and multiplied 0.7 times 0.3 to get 0.21. Right? So you end up with the square root of something, and I can't work with the square root, so I'm going to have to square it. Square both sides, and I end up with 0.0035 equals 0.21 divided by n. Now, you can do the math on this. You can cross multiply if you want to. But I know that if I do that cross multiplication, I'm going to end up with the n on this side and the 0.0035 on the bottom of the fraction. So divide that, and you end up getting 95.95, which is approximately 60 people. Always round up when you're finding sample size. And that's the most math you're going to do in this question, right? A lot of you had questions about that, so make sure if I went through that too fast, rewind it, go back, look at it again. The next part B, it's asking, could there potentially be bias in this type of questioning? And that's absolutely, you're talking to an environmental science teacher who probably thinks that the environment's important, right? And so that person is going to put a pretty high value on recycling. And so when you are asked by that teacher, you want to kind of impress the teacher. Students typically want to impress their teachers, or at least get the right answer, right? And so more students are going to say, yes to this question because of who's asking it, right? They don't want to look negative. They don't want to have a negative outlook from their teacher. And so in order to get credit for this question, you have to do two things. By the way, back to number one. In order to get credit for part A, you had to correctly identify the standard error formula. You had to find p hat. You had to find the margin of error. You had to use the correct z-star, and you had to give a whole number answer. There were 5 elements to getting that right. If you did what I did and worked it out, which I think all those parts are pretty essential. I couldn't have done it without listing those things. But if you left them out and that you didn't put your work down, you would have, if you only got 3 or 4 of those things, you'd get partially credit. But if you missed more than 2 things out of that list, you would have gotten no credit. Let's go on to letter B. In order to get full credit for this one, I had to say a few things. Number one, I had to explain why the students' proportion would have been different from the truth. In other words, they want to impress their teacher. They want to look good. They don't want to look bad because the teacher feels it's important about the environment, right? Number two, I had to say that the students, how the responses might differ from the truth. So I had to add a few things, or I had to add one statement. They were really particular about this one. You couldn't just tell me, it says, describe how the bias might affect the point estimates. Well, let me back it up. It says, given the method used by an environmental science teacher, explain how the bias might have been introduced. Okay, that was talking about the students may want to, that it was the fact that it was the environmental science teacher asking the question. And then it says, describe how the bias might have affected the point estimate of the proportion of all students at school who respond yes to the question. I answered those 2 things, but then they wanted the third thing, which I think was a little nitpicky. They wanted you to say that, and I added it here, that more students would respond yes when they're actually not recycling, right? I think I implied that, but I don't know if that would have gotten credit on the AP test. So would have responded yes when they don't actually recycle. In other words, they're lying. I needed to make sure to give that idea out that they're lying, that they're not just saying yes because they want to say yes or because they actually do recycle. So make sure you state that. That was the third thing. That was the thing that I left off. Okay, moving on. Part C. You can see that here in part C. It gives us the results showed that 213 people said no to the question out of the 300. We know that 50%, because if they flip a coin, then half of them are going to say yes, or approximately half, right? And so we would expect about 150 out of the 300 people to say no. In part 2, it's asking us if the results, we had 213 people said no. Based on that, we want to know what percent of them actually said yes. Well, if 150 people said no, like guaranteed said no, no matter what they felt, then we know that 150 people responded appropriately. Okay? They responded honestly. So a certain percentage of that's going to say yes, and a certain percentage is going to say no. We said that, well, if 213 people said no overall, we know 150 of those said no without a choice. So if I subtract that 150 away from the 213 in this area here, I know that I had 63 people to say no voluntarily, honestly. And so out of the 150 people left that answered the question in an honest way, 87 said yes and 63 said no. And so of those respondents, all right, let me move that up. So when we look at that in this light, 87 out of the 150 said yes in an honest way. I really don't care about the people that said no and were required to, because that's not an honest answer. So out of the 150 honest answers, 87 of those were yes, because if you said yes, we assume that yes was an honest answer. We're assuming they're not lying in this case. Okay, that would mean 58% of the response said yes. To get full credit for this question, I had to do a few things, right? Number one, It's essentially correct if you gave 150 in part A and 0.58 or 58% or something like that in part 2. There are a lot of details about what you had to do to get this right. But essentially, if you simply made those statements, work needed to be given, right? How did you get the numbers? A little bit of work involved. Then you have gotten essentially correct answers. There's a few other options that you can see here that you can get partial credit for. I'm not going to go over those. There's too many to look at. So you can look that up. But this is the first 2 questions on the 2018 test. If you have questions on these, please feel free to email me. I will respond. And then Wednesday, I'll post 2 more. And then we'll try to have a conference, a little video chat on Wednesday. I'll see you guys then. Bye.